Okay, the first thing we're going to do in lesson 85 is solve some trigonometric equations that are just slightly more complicated than the ones that we've seen in the past. In particular, notice that we've got two different trig functions in here, and so this makes it a little bit more complicated. Because in the past we've, set everything on one side, set it equal to 0, factored it, and then used the zero product property to try to figure out what the angles could be. But since we don't have the same angles here, it's not so easy to factor it. Or is it? If we can just do a little bit of substitutions with our trigonometric identities, then maybe we could rewrite it so it can be factored. Okay, so if we look at this page, notice that we've got a tangent squared here. So let's look at, can we make any substitutions for tangent squared? We can. Secant squared x minus 1. And that's already in terms of a secant. So that is looking like it might be a very good substitution to make. So let's go ahead and try that. So make a substitution for tangent squared. We're going to do secant squared minus 1. Okay. So on the left-hand side, we'll have 3 secant squared theta minus 3. And let's go ahead and do what we typically would have done and move everything to one side. So we'll have 3 secant squared theta, and we'll move minus 7 secant. And we'll add 5 to both sides, so that we'll have plus 2. Okay. And now, let's see if we can factor that. Oops, I forgot a theta in here, because I forgot to write theta in the beginning. Sorry. Okay. So, again, let's think about this. It's a little bit maybe easier to think about this being like 3x squared minus 7x plus 2. If you want to think about it being like that, you might have an easier time factoring it. Okay, and so let's see if we had to factor that. Could we do it? Well, the only factors of 3 are 3 and 1. So let's just go ahead with those. And the only factors of 2 are 2 and 1, and we know they're going to have to be negative. Okay, so the only question we have is, should I put the 2 here or should I put the 2 here? Well, to get 7, we're going to need negative 6 and negative 1, and that will give us the positive 2. Alright, so nice factorable expression there. And remember, x was really just secant squared, so this would be secant. 3 secant theta minus 1 equals 0, or secant theta minus 2 equals 0. Okay, so that means over here we would have the secant is equal to 1/3. We add the 1, divide by 3. And here we would have that the secant of theta is 2. Now we're not quite as familiar with the secant function as we are with its reciprocal, so let's turn everything upside down. And so if we take the reciprocal of secant, that would be cosine of theta. Take the reciprocal of the other side, we get 3. Again, the reciprocal of secant is cosine, and the reciprocal of 2 is 1/2. Okay. Well, what angles would give us a cosine of 3? Well, impossible. The highest cosine value you can ever get is 1. So this is, impossible. So we can throw that one out, and we just need to think about where the cosine is 1/2. Okay, so cosine being 1/2. All right, well, for 1/2, we're thinking about an adjacent over hypotenuse kind of relationship here. This would be a 30, this would be a 60, so the adjacent would be 1 over 2, so we're looking at 60 degrees here. And then if you think about the cosine function, you know, here's 1/2, there's one angle here at 60 degrees, but there's another one over here that's 60 degrees back. So from the end, this is 360, and 60 degrees back would be 300. Okay, so those would be the solutions for this particular problem. All right, next. All right, we've got 2 sine squared of x is 3 plus 3 cosine. Again, we've got 2 different trig functions, but never fear, as long as we make a substitution so that everything is in terms of one trig function, we should be fine. And because these all deal with squared trig functions, we're probably going to want to make a substitution for sine squared. So if we look for sine squared, that's 1 minus cosine squared. Okay, so let's make that substitution. Sine squared is 1 minus cosine squared. Okay, so let's go ahead and distribute the 2. We'll have 2 minus cosine, 2 cosine squared x. And let's go ahead and just bring everything over. So we'll subtract the 3 and subtract the 3 cosine x. All right, and so let's go ahead. We'll have negative 2 cosine squared x, and then minus 3 cosine x, and positive 2 minus 3 is negative 1. And multiply everything by negative 1 so we can get a better coefficient in the front. And now let's see if we can factor that. If you want to make the substitution, you can, but maybe, hopefully we can see, all right, this is going to be 2 cosine. The only factors of 2 are 2 and 1, so this would be a cosine x. So that will give us the 2 cosine squared. The only factors of 1 are 1 and 1. And we have a positive number, so they're both going to have to be positive. If that doesn't work, then we'll have to use the quadratic formula. But that's 2 cosine squared, that's 2 cosine, another one, that's 3 cosine plus 1. Perfect. Okay, so that means that we have 2 cosine x plus 1 equals 0. Or, well, I'll just write that out. 2 cosine x plus 1 has to equal 0. Or cosine x plus 1 has to equal 0. So here we would have cosine of x would be negative 1/2. And here we would have cosine of x being negative 1. Okay, so cosine of x being negative 1/2. All right, so at this point, we'd be thinking about a 60-degree angle over here. So we have a negative 1. And that would be 2 and square root of 3. But if that's 60, that's got to be a 120. So here x could be 120. And then of course we have, well, we can just kind of draw our little picture here. Draw it down here. So now here's 180. Here's negative 1/2. So here's our 120. That's 60 degrees this direction from one. Oops, here you can't see my picture. Sorry. Okay, so 180 is right in the middle of our cosine. So here's negative 1/2. Here's, you know, our 120 degrees. That's 60 degrees back. So the other one over here that's also negative 1/2 would be 60 degrees on the other side of 180. So that would be at 240. And then if we think about where the cosine of x is -1, that's down here at 180 degrees. So those are our three solutions for this problem. Okay. And you get the idea of what we're going to do. This might even be a great time to stop the video, make a substitution for a squared one, see if you can factor it, and then you can just fast forward through mine and make sure I did it like you did. Or if you get stuck, then you can fast forward up to the point where I'm at where you get stuck. Okay, so we want everything probably in terms of secants. So if we can make a substitution for tangent squared that involves secants, we'll be good. And we've already done one like that. So tangent squared is secant squared -1. So we can substitute secant squared -1. And we can go ahead and distribute the 2 through, so we'll have 2 secant squared theta -2. Let's bring stuff over. Minus secant plus 1. So we have 2 secant squared theta minus secant theta -2 plus 1 is -1. And if we factor that, again, the only factors of 2 are 2 and 1, so we'll have 2 secant and secant. And the only factors of 1 are 1 and 1, but to get a -1, one of them has to be positive and one of them has to be negative. We want the sum to be negative, so we need the 2 to be a negative, the 1 to be a positive. So we'll have -2 plus 1 will give us the -1. Alright, so that should be a good factoring for that one. And now we can do that 2 secant theta plus 1 equals 0, or secant theta -1 equals 0. So over here we would have secant is 1, and here we would have secant of theta is -1/2. Again, we're not too familiar with the secant function, but we are familiar with the reciprocal function. So let's take the reciprocal of both sides. Oops, cosine. Alright, and once again, we know that the lowest cosine value we can ever get is -1, so that's not even a possibility. So this is the only one we have to consider and think about our cosine function. The only place between 0, less than 360, that it's 1 is right here at 0. So 0 is the only angle that will be a solution for this particular problem. Okay, so these are just putting together two things. We've already, if you had a problem like this, we've already done lots of these. The trick is just getting to what they give you, using your trig identities to make a substitution to get it into a form that you know how to solve, because you've done these lots of times before. Okay, so those problems hopefully won't give you too much problems, and hopefully you are getting used to using this table now, and you've almost have some of them memorized. Okay, the next set of problems in this section are these clock problems. And really, they're just sort of a variation of rate problems. So if you think about if we have a clock, okay, and we consider, let's say, the hour hand on here. Okay, the hour hand moves at a certain rate. So if you think about it, the hour hand will move and it'll start at the 12, and then in an hour's time it will have moved over to the 1, right? So if we think about the rate at which the hour hand is moving, the rate of the hour hand, and if we think of each one of these little tick marks here as being one space, okay, it will move 1, 2, 3, 4, 5 spaces in 1 hour. Or let's think about that as being 5 spaces in 60 minutes. And if we reduce that, that would be 1 space every 12 minutes. Okay, so the hour hand, in 12 minutes it'll be there, 12 minutes later there, so it's moving kind of slowly, and after 60 minutes it'll be pointing over at the 1. And that's the rate at which that hour hand is moving. Okay, the minute hand, on the other hand, is moving much faster, right? So if we have a minute hand, I'll just draw it somewhere else, pointing there. Okay, it will move one of these spaces every single minute. All right, so the rate for the minute hand is 1 space per minute. Okay, so it's moving at a much faster rate. So if we think about these problems as rate problems, then in general we'll just have this, that the number of spaces moved by either the hour hand or the minute hand, we'll just say number of spaces moved, is going to be the rate that it's moving in spaces per minute times the number of minutes that we're looking at. Imagine minutes will cancel out, minutes will cancel out, we'll just have spaces equals spaces moved. So in general, that's just kind of the general idea that you want to think about with these problems. Okay, so how many spaces would the hour hand have moved? How many spaces would the minute hand have moved? And to figure that out, we'll just look at the rates at which they move times the number of minutes that they've been moving, and then we'll have various other characteristics to make equations to solve the problem. So let's look at an example. Okay, the hands of a clock point in the same direction. Okay, so we're starting so here we've got, let's just say they're starting here. Here's our hour hand, here's our minute hand, and they're pointing in exactly the same direction. So, and how many minutes will they point in opposite directions? So some time is going to go by, and our hour hand will have moved a little bit. And we want our minute hand, which is moving much faster, to be opposite it. So it's going to move all the way over here. So this is the kind of situation we're looking at. So first of all, let's think about the number of spaces that the hour hand moved. So the number of spaces that the hour hand moved is going to be the rate that the hour hand moves, and we already know that that's 1 space every 12 minutes times the amount of time that it's been, so let's just say t minutes that it's been moving. Okay, so this is going to be 1/12 t spaces that it's moved. Okay, in that same amount of time, we start these at the same time, they're running the same amount of time, the number of spaces that the minute hand has traveled is its rate, which is just 1 space every minute, times the t minutes that we've been watching the clock. So in this case, this has gone t spaces. Okay, and now let's think about the relationship between these number of spaces. So here, the minute hand had to move the same number of spaces that the hour hand did, and then it had to move an additional 30 spaces so that it would be opposite the hour hand. So if we look at the number of spaces that the minute hand moved, that would have to be the same number of spaces that the hour hand moved, plus an additional 30 spaces to be opposite from it. Okay, well, we know that the number of spaces the minute hand moved was t. We know that the number of spaces that the hour hand moved was 1/12 t. And then we have our 30. Okay, and so now we just need to solve for t to figure out how many minutes it took for this to happen. So if we subtract the 1/12 t from both sides, we get 11/12 t equals 30. And then multiply both sides by 12/11. So we'll have 12 times 30, or 360 over 11 minutes. Okay, and let's see, 11 would go into there. We'll go ahead and do a little bit of cheating. So 360 divided by 11. So that's 32 minutes. Okay, 32 times 11 is 352, and then there would be 8/11 left. Okay. So it took just a little over half an hour for the hands to be opposite. And that kind of makes sense, right? You know, in half an hour you expect these hands, you know, this one that's moving slowly, this one will in half an hour should be opposite it if they started at the same place. But there is, you know, a little bit of time over the half an hour where both hands are moving and it kind of has to catch up. So that's a very reasonable answer. Okay. All right, we'll try one more of these. These are kind of, you have to just think about them. They're maybe not everybody's favorite kinds of problems. Like, I generally like to draw pictures to wrap my brain around them. Usually if you can draw a picture, I can usually get this kind of relationship that we need to figure out. Okay, it's 3 o'clock. In how many minutes will the two hands of the clock point in the same direction? All right, so if we were to draw ourselves a picture, it's 3 o'clock, which means the hour hand is pointing at the 3 and the minute hand is pointing up at the 12. Okay, and we want to eventually have them pointing in the same direction. So a little bit of time will pass, and the hour hand, maybe I'll just draw it in different pictures, colors, so it's not, okay, it will be there, and we want the minute hand also to be pointing in exactly the same direction. So it's moving faster, it's going to have to go a little bit farther. So, I mean, once again, we have that the number of spaces, of individual spaces that the hour hand moves is its rate, which is 1 space every 12 minutes, times the number of minutes that it's been running. Let's say it's t again. Okay, so we'll see that we get this 1/12 t all the time. That's how many spaces it moves. And then the minute hand, just like before, it moves 1 space per minute. And it's also been running for the same amount of time, t minutes, so it's going to move t spaces. So the key to solving the problem is, what's the relationship between these two? Okay, well, they both had to move, you know, this amount of time, but the minute hand had to move an extra 15 spaces in addition to these extra. So they both had to move these spaces, but the minute hand had to move the extra 15. So if we look at the number of spaces that the minute hand moved, that's going to be the same number of spaces that the hour hand moved, plus that extra 15 spaces that it had to sort of catch up and overtake it. Well, the minute hand's spaces, that's just t. The hour hand spaces was 1/12 t. And so now we can just solve for t. Okay, again, we've got 11/12 t equals 15 this time. Multiply both sides by 12/11. 15 times 12 is 150, plus 30 is 180. Okay, and so, okay, this has got to be a little bit less than 18. This, if we did 17 times 11, we'd get 187. Oh, that's too big, so it's got to be 16. 16 would be 176, so there would be 4 left over and 4/11. So 16 and 4/11 minutes. And that kind of makes sense again, because you'd expect it to be just a little bit more than 15 minutes. Because in 15 minutes, I mean, this is moving really slowly. In 15 minutes, okay, it has caught up, but this one, because it moves one every 12 minutes, it's already moved one. So it's going to take a little bit less than, just a little bit more time before it catches up. Just a little bit over 15 minutes. All right, so draw yourself some pictures, and hopefully those problems won't give you too much issue.